Hi, in this video we're going to solve A-Level Mechanics paper 41 from May-June 2022. Okay, let's have a look at question 1. The question is about Szilard equations, and before I start solving it, I'm going to draw a diagram to have a better understanding of what's going on. Okay, so the car is moving on a straight line. It starts from rest, so initial velocity equals to 0. And it moves on a straight line with a constant acceleration, so a is constant, for the distance of 200 meters, reaching the speed of 25 meters per second. So I'm going to draw v equals to 25 meters per second, and then we keep moving with the same speed for another 400 meters. After that, we're going to decelerate uniformly, so there's a constant deceleration for the period of 5 seconds, and that means we're going to reach velocity of 0 meters per second. Okay, now the problem is broken down on a diagram, and now it's easier to work with. Right, so for the first question, find the time for which the car is accelerating. We need the Szilard equation which connects distance, initial velocity, final velocity, and time. And this equation is s equals to initial velocity u plus v over 2 times time. Let's substitute all the numbers into this equation. Distance is 200. We start from rest, so u is 0. And then we reach the velocity of 25, so v is 25 over 2 times t. Now finally, we can find t from here. T equals to 200 times 2 over 25. And that gives us 16. That's my answer for the first question. Answer, 16 seconds. Question 2. We have to sketch the velocity time graph. First of all, let's draw the axis. Y-axis is going to be velocity in meter per second. And the horizontal axis is going to be the time in seconds. Right, so for the first part of the motion, look at the diagram. We are moving with a constant acceleration, so that means our graph is going to look like a straight line. We move for 16 seconds, and we'll reach the velocity of 25 meters per second, starting from 0, 0. So here we go, that's our first part of the motion. Next, we continue driving with the same velocity for 400 meters. Now, how long is it going to take? Let's find it out. Distance is 400 meters and velocity is 25. So that gives us 16 seconds. So I'm going to continue this line for another 16 seconds. And altogether now it's 32. Next, we're decelerating. Again, it's going to be a straight line, descending. We decelerate to rest for 5 seconds. So we're going to reach the velocity of 0 at 37 seconds. Here we go, that's our velocity time graph with all the key points. Next question, find the average speed of this car during the motion. Now, average speed is equal to the total distance traveled, total distance, divided by the total time. How do we find the total distance from the velocity time graph? That's going to be the area under this graph. The graph is a trapezium, and the area of a trapezium is base 1 plus base 2 over 2 times the height. Base 1 is 37. Base 2 is 16. Divided by 2, and the height of this trapezium is 25. That gives us 662.5. Okay, now we're ready to find the average velocity. We take the total distance, 662.5, and divide by the total time, which is 37. And we get 17.9. Okay, that's the final answer. 17.9 meters per second. Let's move on to the next question. Connected particles, and again I'm going to start with the diagram. We have two particles, P and Q, connected with a string. P is vertically above Q, like this. The mass of P is 0.5 kilograms, so that means its weight is going to be 5 newtons, and the weight of Q is going to be 3 newtons. Now the force of magnitude 10 newtons is applied to P vertically upwards, like that. Now we have to find the acceleration of the particles and the tension in the string. Okay, now let's draw the force of tension. If you look at the particle P, then it is being connected with Q, so the string is trying to pull the particle downward. Now, if you look at the particle Q, the string is lifting it up, so tension is pointing up for the particle Q. Now, what I'm going to do is to write the second Newton's law, the sum of all forces equals to mass times acceleration, for each particle individually, starting with the particle P. Now let's say y-axis is pointing up. So 10 newtons on particle P upwards, so I'll take it with a plus sign. Also we have 5 newtons pointing downwards, the opposite direction of my y-axis, so I will take it with a negative sign. We also have the force of tension acting on the particle P downward, so it's going to be minus. And all of that equals to ma, which is 0.5 times acceleration. Now particle Q. Same idea. All the forces, but only we have to be careful with plus and minus sign. Force of tension is upwards, and so is y-axis. That means I will take it with the plus sign. 3 newtons downwards, minus. And that equals to ma, which is this time 0.3, the mass of the particle Q times acceleration. And I don't have to worry about acceleration being different for both particles because they are connected. Now all I have to do is to solve the simultaneous equations. Simplify a little bit. 10 minus 5 is going to be 5, minus t equals to 0.5a. And for the second equation, we got t minus 3 equals to 0.3a. Now I can add up both equations to get rid of t. Minus t plus t is 0. 5 minus 3 is 2. And 0.5a plus 0.3a is going to be 0.8a. Now from here, divide both sides by 0.8 and get the acceleration. So a equals 2.5 meter per second square. Now substitute it back into any of the equations. I'll probably choose the second one. T equals to 0.3a plus 3. And we'll get the force of tension. Okay, I got 3.75 newtons. Did we answer the question? Yes, we found the acceleration and we found the tension in the string. Let's write down the answer. Tension equals to 3.75 newtons. and acceleration equals to 2.5 meters per second square. Let's move on to the next question. Again, I'm going to start with the diagram. We've got the horizontal ground and a crate of mass 300 kilograms. We've got the coefficient of friction, mu, equals to 0.5. And we also have the force of x newtons acting at an angle alpha. Let's say this is x, and that is going to be alpha. We know that sine alpha equals to 0.28. And we have to find the greatest value of x for which the crate remains at rest. Before we do anything else, let's make sure that we draw all the forces acting on a crate. Apart from x, we've got the weight of the crate, which is 3000 newtons. And we also have the normal reaction of the ground. I'll use n for that. Apart from that, we also have the force of friction acting in the opposite direction of x, but horizontally, force of friction. Okay, now the crate remains at rest, so that means acceleration of the crate is 0, and that means the sum of all the forces in every direction should be 0. Now let's start with choosing x and y axis. I will choose x-axis to be horizontal, pointing to the right, and y-axis is going to point upwards. Now we're ready to write the second Newton's law on both axes. Let's start with x-axis. We got a force x acting in the same direction as the axis, so I'll take it with a plus sign. But the only thing is, I need the horizontal component of x. It is adjacent to angle alpha, so I will have to multiply x by cosine alpha. Next, we have the force of friction acting to the left. So that's the opposite direction of x, and I will take it with a negative sign, so minus force of friction. Are there any other forces acting on x-axis? I don't see any, so I will just say it equals to 0. And move on to y-axis. Now, on the y-axis, we also have the y component of the force x, which is vertical. And it is opposite of the angle alpha. That means I will have to multiply x by sine alpha. We also have the normal reaction, and it's pointing upwards, same direction as y. So I'll take it with the plus sign. And we also have the weight of the crate, which is pointing downwards, opposite of y-axis, so I will have to subtract it. Minus 3000. Okay, and all the forces on the y-axis are also balanced, so that means the sum equals to 0. Apart from that, we know the connection between the force of friction and the normal reaction. Force of friction equals to the coefficient of friction, mu, times n. And these are our simultaneous equations that we have to solve. Okay, let's start solving by sorting out sine and cosine alpha. In the first place, we know that sine alpha is 0.28. And we also need cosine alpha. We can calculate the inverse sine of 0.28 and then take the cosine. So cosine alpha is going to be cosine of the inverse sine of 0.28. And I got 0.96. Okay, next step, let's substitute sine and cosine into the simultaneous equations, and I will get 0.96 x minus force of friction. We know it's mu times n, mu is 0.5, so 0.5 n equals to 0. And we move on to the second equation for y-axis. Sine alpha is 0.28, so 0.28 x plus n minus 3000 equals to 0. Remember, we're looking for x, so we kind of have to get rid of n. And I will make n the subject of the formula from the second equation. So n equals to 3000 minus 0.28x, and substitute it into the first equation. So I'll get 0.96x minus 0.5 times 3000 minus 0.28x equals to 0. Now expand the brackets. 1500 plus 0.14x equals to 0. So that means I got 1.1 x equals to 1500. Now divide both sides by 1.1 and I will get x equals to 1363.6. That is going to be my answer for that question. Answer 1363.6 newtons. Let's move on to the next question. Okay, very similar. We have three forces. They are all in equilibrium. Find F and alpha. Okay, let me zoom out a little bit. To start with, let's choose x and y axis in a very typical way. Y is pointing upwards, x is horizontally to the right. And now, because all the forces are in equilibrium, that means there's some in direction of x-axis, so fx must be 0, and the sum of all forces acting on y-axis should also be 0. And let's start with x-axis. So we got the force F, and it also has the horizontal component. This is going to be Fx. Now, this force is adjacent to angle alpha, so to find it, I would have to multiply F by cosine alpha. It's acting to the right, and so it's the same direction of of x-axis. So that means I will take it with the plus sign, F cosine alpha. Next, we got 20 newtons, and its x component is acting to the left. It's opposite direction of x-axis, that means I will take it with a minus sign, minus 20. The x component is adjacent to the angle of 40 degrees, so I will multiply it by cosine 40. Last but not least, we've got the force of 100 newtons. And the component of the force parallel to x-axis, this time is opposite of the angle of 20 degrees, so I'll have to multiply it by sine 20. And also it's acting to the left, that means minus 100 sine 20 degrees. And that should be equal to 0. Let's move on to y-axis. Starting with the force F, the y component of this force is opposite of angle A, so I'll have to multiply f by sine alpha and take it with a plus sign because it's acting in the same direction as y-axis. So we got f sine alpha. Next is going to be the force of 20 newtons. Its y component is opposite of the angle 40 degrees, acting up. So take plus 20 sine 40. And finally, the force of 100 newtons. It is acting down on y-axis, so minus, and the y component is adjacent to the angle of 20 degrees. So we'll have to multiply by cosine. So minus 100 cosine 20. And that equals to 0. These are simultaneous equations. I have to solve for f and alpha. To start with, I will take the second equation and move 20 sine 40 and 100 cosine 20 to the other side. And I will have f sine alpha equals to 100 cosine 20 minus 20 sine 40. Now the equation on top, I'm going to do a similar thing. I will leave f cosine alpha on the left and everything else will go to the other side. Now, why did I do this? That's because if I divide equation on top by equation at the bottom, f will cancel out. So I get f sine alpha over f cosine alpha. That's what happens if I divide left side by the left side. F cancelled out, and sine alpha over cosine alpha, that's going to be tangent alpha. Now let's divide the right side by the right side. So I get 100 cosine 20 minus 20 sine 40 over 20 cosine 40 plus 100 sine 20. Now, get your calculator and take the inverse tangent of this fraction. Okay, I got 58.6 degrees. Okay, and now we're ready to find f. I can substitute it into, let's say, the second equation, but feel free to choose any. So f is going to be 20 cosine 40 plus 100 sine 20 over cosine 58.6. Now, substituting this into the calculator gave me 95.05. And I will give both values as my final answer. So the force equals to 95.05 and the angle equals to 58.6 degrees. Next question. Okay, again, we're going to start with the diagram. We have a straight horizontal track. I'll try to draw it as straight as I can. They start at point O. They are alongside to each other, so A and B. Okay, the engine of A produces the constant driving force of 4,000. So F driving equals to 4,000. 500 newtons. Now we also have point P somewhere, and A arrives at point P with a speed of 25 meters per second. Okay, so V equals to 25 meters per second. The distance OP is d meters, okay, d meters. And the work done against the resistance experienced by A between O and P is 75,000 joules. Let's write it down as well. Work against resistance equals to 75,000 joules. Show that D equals to 100. Okay, now we've got the work done against the resistance, and we also have the driving force. Right, so that means the engine of the car is producing some work. Say work by engine. Now, what happens to this work produced by the engine? It doesn't disappear because it's being transferred into something else. To what? Well, we have work done against the resistance. And also, we increase the kinetic energy of the car. So I'm going to say plus energy increase. Now, we already know that the work done against the resistance is 75,000. What's the energy increase? The track is horizontal, so the only kind of energy which is increasing in that case is kinetic energy. And we know it's mv squared over 2. Do we know the mass of the car? Yes, I forgot to write it down. It's 1,200 kilograms. 1,200 times 25 squared over 2. Now, what about the work done by the engine? Technically, the force, the driving force, is doing the work. And that's what we mean by work done by the engine. It is work done by the force, the driving force. Now, how to find this work? We have to multiply the force by the distance. So we're going to times 4,500, the driving force, by the distance. And from here, we can find the distance if we solve that equation. Let's simplify first a little bit. 4,500d equals to 450,000. Now we can divide both sides by 4,500, and we get d equals to 100 meters. So that's exactly what I was supposed to show. Great success. All right, question B. Now we have the second car, which starts off at the same instant as car A. Okay, they arrive at point P simultaneously with the same speed. Let's get back to our sketch. So they arrive simultaneously at point P with a velocity of 25 meters per second. Okay. The engine of B produces a driving force of 3,200 newtons. Let's put this on the diagram as well. The driving force equals to 3,200 newtons. What else do we know? We know that there is a resistance of 1,200 newtons. So the force of resistance equals to 1,200 newtons. Okay, find the mass of B. I think we can use the same principle. So the work done by the engine, or technically the work done by the driving force of the engine, is going to be equal to the work done against resistance plus the increase of kinetic energy increase. Now we know that the distance is 100 meters, and if I'm looking for the work done by the driving force, I will have to multiply 3,200 by 100. Now that equals to work against the resistance. Now we know the force of resistance is 1,200, so the work is going to be 1,200 times 100 plus the energy increase. That's going to be mv squared over 2. We don't know m, okay, leave it as a variable. Velocity is 25, so 25 squared over 2. So that's the equation to find m. Okay, let's move this to the left side, and we'll get 200,000 equals to 625 m over 2. And from here we can solve it for m and get 640. And that's going to be my final answer. Answer m is 640 kilograms. Okay, next question. Find the speed which B can maintain when its engine is working at the same rate as it is at point P. So when I talk about the rate of producing work, that means work over time, which is power. Now, whenever you have the question about vehicles, engines, and power and driving force, there is a formula that should automatically come into your mind, which is power equals to the driving force times the velocity. Now, let's try to think about what's happening when the speed of B is constant. That means we still have the driving force and we still have resistance. But if the speed is constant, there is no acceleration. That means the driving force is being the same as the force of the resistance. Driving force equals force of the resistance. Now, do we know the force of the resistance? Yes, it is 1,200 newtons, so it means the power is going to be 1,200 times the constant velocity which we are looking for. Now, let's think what happens at point P. We still have the driving force. It is 3,200 newtons. It's being given in the question. And the velocity is 25 meters per second. Multiply these together and get 80,000. Now, we know that the power, when velocity is constant, this one, is the same as the power of the engine at point P. So what I can do, I can say that 1,200 V equals to 80,000. And that's my equation to find V. Divide both sides by 1,200, and I will get 66.7 meters per second. And I will state this as the answer. Next question. Okay, now we have a question and we got the formula for the velocity. And we have to verify that the particle returns to O when t equals to 2. Now, this question is going to be about integration and differentiation. It's very useful to remember that if you're trying to get from acceleration to velocity, you will have to integrate with respect to dt. If you want to get the coordinate of the particle from the velocity, you will have to integrate again. If you're trying to get velocity from the coordinate, you will have to differentiate with respect to t. And if you're looking for acceleration from the velocity, you will have to differentiate again. Now, we're given the formula for the velocity. And when I say that we have to verify that the particle returns to O, that means we'll have to find a coordinate of that particle. So that means we'll have to integrate the velocity. So I'll say s equals to the integral of v dt. Let's substitute v in the integral. Now, k is constant, so let's move it out of the integral. Okay, let's integrate. K times increase the power by 1, divide by the new power, minus 2t, increase the power by 1, divide by the new power. And now don't forget to add c. Let's simplify that. So get k times t cubed minus t to the power 4 over 2 plus c. Now we know that the particle starts from point O when t equals to 0. So that means when t equals to 0, we need to get s equals to 0. And that will help us to find c. 0 equals to k times, substitute 0 in the brackets, we get 0 plus c. So that means c equals to 0. And we get the formula for the coordinate s equals to k times t cubed minus t to the power 4 over 2, and c equals to 0. Okay, now we have to show that when t equals to 2, the particle returns back to O. So substitute t into the formula. So s of 2 is going to be k times 2 cubed 8 minus 2 to the power 4 16 over 2, which is 8. So all in all, we got 0. Verified. Okay, let's have a look at the question B. Now we're given that the acceleration of the particle is minus 13.5 meters per second square for the positive value of t at which v equals to 0. And we're looking for the value of a constant k and the total distance traveled for the first 2 seconds of motion. So s when t equals to 2. Right, so first of all, we're giving that velocity equals to 0. Let's find that value of t they're talking about. So the formula for the velocity is already given. It is here, yes, so k times the bracket 3t squared minus 2t cubed. Net velocity equals to 0. Right, now this equation will help us to find t. First of all, divide both sides by k and we'll get 3t squared minus 2t cubed equals to 0. Now factorize it, bring t squared outside and I get 3 minus 2t equals to 0. Split in 2, got t equals to 0, or 3 minus 2t equals to 0. And from here we can find t. T equals to 1.5. Now that means if t equals to 1.5, then a acceleration is going to be minus 13.5. Now, how do we get the formula for acceleration? We know the one for the velocity, and remember, to get from velocity to acceleration, we'll have to differentiate with respect to t. So a equals to d over dt of k times 3t squared minus 2t cubed. I'll have to differentiate this, so bring k outside, differentiate the bracket, got 6t minus 6t squared. Okay, and when t equals to 1.5, this should be equal to minus 13.5. So I will substitute t equals to 1.5. Okay, times 6 times 1.5 minus 6 times 1.5 squared. And that equals to minus 13.5. Right, let's do calculations in a bracket. I will get minus 4.5k equals to minus 13.5. Then divide both sides by minus 14.5, minus 4.5, and we get the value of k, which is 3. So the formula for the velocity equals to, substitute 3 in here, so got 3 times 3t squared minus 2t cubed. Okay, so that's the cubic function. We know when t equals to 0, go through 0. And let's draw the sketch. So it looks somewhat like this. Right, we know that velocity equals to 0 when t equals to 1.5. Let's also substitute t equals to 2 into the velocity to see if that point is here or if this point is here. Okay, 3 times 3 times 4 minus 2 times 8. Got 12 minus 16, so it's still going to be negative. Okay, so now we know that t equals 2 belongs to this part of the graph. Right. In order to find the total distance traveled, we'll have to integrate velocity, and we'll have to split it into 2 parts. Why? Because this integral, s1, is going to be positive, and that integral from 1.5 to 2 is going to be negative. But because we're looking for the total distance traveled, we'll take the second integral with a positive sign. Okay, so s1 is going to be the integral from 0 to 1.5 of the velocity so it's 3 times 3t cubed divided by 3 minus 2t to the power 4 over 4 from 0 to 1.5. Let's simplify it a little bit. So we got 3t cubed minus 3t to the power 4 over 2 from 0 to 1.5. Now substitute all the numbers in, substitute the upper limit and the lower limit. Get 3 times 1.5 cubed minus 3 times 1.5 to the power 4 over 2. And we got 81 over 32. Now for the second integral, it's going to be the same formula, 3t cubed minus 3t to the power 4 over 2. We have to integrate from 1.5 to 2. Then if I substitute those limits, upper limit minus the lower limit, I got minus 81 over 32. So that means that the total distance traveled is going to be 81 over 32. Now remember, I will have to take the second integral with a positive sign, plus 81 over 32. And that gives me about 5.06 meters. Ran out of space a little bit. Okay, let's have a look at the last question, 7a. Again, I'm going to draw a diagram. We have an inclined plane. The angle is 30 degrees. And we've got two particles, A and B. Particle A, particle B down there. The mass of particle B is 0.2 kilograms. Particle A is 0.4. Now those particles are going to collide with the speeds of A being 3 meters per second, particle B 2 meters per second. And now we know that after the collision, the speed of A is reduced to 2.5, so it kind of looks like this. (2.5 meters per second), and we are looking for the velocity of particle B right after the collision. Okay, so for all those collision questions, the best idea is to use the conservation of momentum. M times v before the collision equals to the sum of m times v after the collision. So before the collision, the total momentum of the system was 2 times 0.2, that's for the particle B, plus 3 times 0.5, and that must be equal to momentum after collision, which is 0.2 times velocity of the particle B, plus 0.4 times 2.5. That's for the particle A. And from here, we can find velocity of B, which is equal to 3 meters per second. That's the final answer. And let's move on to the very last question, which is 7 marks. Okay, great. It's probably going to take a while. And again, we're going to start with the diagram. The angle of 30 degrees. Now the collision has just happened. We got particle B and A. B 0.2 kilograms, A 0.4. Velocity of B is 3 meters per second right after the collision, and A is 2.5 meters per second. Now they're traveling down, and the distance is 1.6 meters. And then at the end of the slope, there is a barrier, like this. Okay, and the time taken for the particle B to travel down there is 0.4 seconds after the collision. And now here it's going to reduce, it's going to lose 90% of its velocity. And then the particle B is going to travel up. When it's going to collide with A. And then they're going to stick together. By that time, 0.44 seconds will pass. Okay, and we're looking for the velocity of the combined particle immediately after the second collision. Okay, but before that, let's find velocity of B before it hits the barrier. I'm going to call it velocity B down the slope. Okay, for that, I'm going to use the law of conservation of energy. So energy on top the plane must be equal to the energy right before the collision with the barrier. So mass times u squared over 2, that's the kinetic energy of particle B on top of the plane, and it also has potential energy because there is some height as compared to this level. So plus mgh. So that's the total mechanical energy of particle B on top of the inclined plane. And when it just before it hits the barrier, there's only kinetic energy, which I'm going to call mv squared over 2. Now, we seem to know everything apart from the height, but it's quite easy to figure out. Look at the triangle. The hypotenuse is 1.6, and I'm looking for the height of the triangle. We got this angle 30, and the height is opposite of the angle 30, so all I have to do is to multiply 1.6 by sine 30. Sine 30 is a half, so I got 0.8. Now we're ready to substitute everything into the energy equation. Mass is 0.2, so 0.2 times u is 3, so times 9 over 2 plus m 0.2 times g 2 times the height is 1.6 equals to mass 0.2 times velocity, we don't know, v squared divided by 2. Okay, from here we can find v after just simplifying a little bit. We got 0.9 plus 1.6 equals to 0.1 v squared. Add up 0.9 and 1.6, we get 2.5 equals to 0.1 v squared. Divide by 0.1 and take the square root, so we got v equals to 5. So that's the velocity of particle B right before the collision with the barrier. Now, what happens when it collides with the barrier? It's going to lose 90% of its velocity, so what is left is 10%. Now we're looking for 10% of 5 meters per second. That's going to be 0.5 meters per second. So that's the velocity with which particle B starts traveling up. Now let's draw the diagram for the next part of motion. The particle B starts going up from the barrier with the initial velocity of 0.5 meters per second, and then at some point it's going to collide with particle A. Let's say collision happens somewhere here. Now, I want to know the velocity of B and A right before the second collision. Before the second collision. Okay, I know that the particle B has traveled for 0.4 seconds down to the barrier, and it takes 0.44 seconds before the second collision. So that means the time for the particle B to travel up before the collision is going to be, I'll call it time B, equals to 0.04 seconds. Okay, now I want to know the velocity of B before the collision, and the only force acting on this particle is the force of gravity. So acceleration of the particle B is pointing downwards, and it equals to 10 meters per second squared. However, the particle is moving up the plane. So I will choose my x-axis this way. And y-axis is going to be perpendicular. Now, the only component of the acceleration acting on x-axis is going to be this, ax. So it's the x component of 10 meters per second squared. Now the angle in here is going to be 30 degrees. And the x component is opposite of that angle. So that means I will have to multiply 10 meters per second squared by sine 30. Sine 30 is a half, so acceleration on x-axis is 5 meters per second squared. Now, this will help me to find velocity of b before the collision. It is going to be initial velocity 0.5. Now, the particle is decelerating because it's moving upwards. So I'll take minus acceleration times time, 0.04. Okay, and I got 0.3 meters per second. Okay, so for the particle A, now particle A has taken 0.44 seconds to travel from the first collision to the second. So t is going to be 0.44 seconds. And we know that the initial velocity was 2.5. So velocity of A before the second collision is going to be, I'm using u plus at, 2.5. Now, the velocity of A is increasing because it's going downwards, down the hill. So plus 5, that's the x component of acceleration, times the time, 0.04. And I got 4.7 meters per second. Okay, so those are velocities right before the collision. Now, to find the velocity after the collision, we will have to use conservation of momentum one more time. Particle B, then particle A. Okay, velocity of B is 0.3 meters per second. Velocity of A is 4.7. The mass of B, I forgot what it is. B is 0.2, A is 0.4. And let's choose x-axis to point upwards. Okay, before the collision, 0.2 times 0.3. That's for the particle B. Now, particle A is moving down the hill. And x-axis is pointing upwards, so I will have to take this momentum with a negative sign. So minus 4.7 times 0.4. So that's before the collision. Then after the collision, they're going to stick together, and their total mass is going to be 0.4 plus 0.2, which is 0.6, times the unknown velocity, the one we're looking for. Okay, and from here we can find the velocity. I got v equals to minus 3.03 meters per second. Why minus? Because I assume that this velocity after the collision is positive, so I can't assume that it's going up. I got negative value, so that means the combined particle actually is moving downwards. Anyway, we are ready to find the state state the final answer, which is 3.03 meters per second. And that was the last question. Okay, I hope that was helpful. If you got any questions, please feel free to let me know in the comments to this video. And you can also find my notes in the description to the video, as well as the clean paper, so you can just try to solve it yourself. Thanks a lot for watching. Bye.